More truss problems, that's what we're going to cover here in this video. This is going to be over method of sections. Now I know after method of joints you are probably like, I'm tired of doing these truss problems because they take forever, but method of sections is actually not as bad. Now if we only need a few forces, not all of them, method of joints we got all of the forces, but if we only need a few forces, this method that we're going to talk about now is shorter. Right, shorter is good. We don't want to use method of joints and find everything if we don't need to do that. Right? We always want to go with a shorter method if possible. Now, method of sections is going to use the theory that all parts of a body that's in equilibrium, then all the parts have to be in equilibrium. All right, so if we've got a truss, let's say we've got this, and this truss is in equilibrium, then every part of this truss is also in equilibrium. And that makes sense, right? So what we're going to do with method of sections is we're going to cut or section members of our truss. Essentially, we'll be cutting our trusses in half, and then we're going to look at each side, for example. So you're not going to have to go through and analyze all of the different joints like we did in the last section with method of joints. Now once we go through and section our trusses, then we're going to use our equilibrium equations to find the forces in the members at the cut section. All right, so it's actually really pretty simple and straightforward. Now our equations of equilibrium, we pretty much know those already. Nothing really new here. Sum up your forces in the x and y directions, set them to equal to 0. We can also use that moment equation. Or if you really want to get crazy here, you could sum up forces in the x direction, set it equal to 0, and then find moments about 2 different points. Set those equal to 0. Right. Either way, you have 3 equations. How many unknowns can we solve with those? Hopefully you said 3. All right, so we can solve for, at most, 3 equations. All right, so there are our equations. Now what we're going to do is we're going to select a section that passes through no more than 3 members with unknown forces. And the reason why we don't want any more than 3 members with unknown forces is because of what we just said here, right? Because we can only solve for 3 unknowns. So it makes sense. We only want to have 3 unknowns at our cut. Now let's look at this one. We're not going to solve this problem. I'm just going to show you how to set up the free body diagrams on this one. So let's say for this one, I want to find the forces in members GE, GC, and then BC. I want to know these 3 forces. Okay? I don't care about these over here and over here. So I don't need to use method of joints because I only want 3 things. We're going to use method of sections. So what you would do is you would basically just cut this thing right down the middle. Okay, and this is going to be our cut or our section. Now what we're going to do is we're going to basically break this apart, and you can draw free body diagrams for each side. Okay, and since this whole truss is in equilibrium, each side has to be in equilibrium also. All right, so let's do the free body diagram for each one. All right, so we've got that's going to be our left side. And now what we're going to do, we want to put our external support forces on here, so our reaction forces. Here, if we have this pin, we would have AY and then AX. And now we've cut through these members, so now we've got forces in those members. So what we're going to do is we're going to draw forces here representing the forces in those members. And again, draw them going out. It's going to be easier that way. Just always have them going out of the section. So here we have BC, GC, and then up here let's have GE. Okay, so this would be one section. Now, if we wanted, we could go ahead and then solve for these three forces. You would have to previously have solved for AX and AY by looking at the whole truss like we did in the method of section or method of joints. I'll show you that in the examples. So we will have already calculated these two things. So these three would be our only unknowns. All right. Now the other side over here, if we drew the diagram for that, would be something like this. We've got a roller here, so we would put that on here. Now we would have already solved for this value earlier. We have this applied force at C, and then we have one at E, so put those on there. And then you've got the three forces that you cut through. So there are forces going through those members, so you just draw your force going out again, and then label it. So BC, now notice, equal opposite. All right. This one here is GC, and then here is GE. So again, now you would have these three unknowns because we would already know this one. And then you could use your equilibrium equations to solve for that. Okay, so that's kind of what we're going to do with method of sections. And again, let's make sure we have a note here that you got to pay attention to make sure when you're cutting through that you have equal and opposite. And you always will if you always go out. But just make sure that we have that. Okay. So now, that's all we want to talk about for the lecture part. Let's go ahead and we'll stop this video. We'll pick it up in the next one with one of the examples.